Alright, welcome back, y'all. Last time we had a pretty big revelation where we were having some real messages with the meteor. Um, Basically, we discovered that it's referring to itself. We now have a name for Earth, an alien. In fact, Earth could maybe be human. I don't know, but see, we'll see how we get along here. And right off the bat, we have a new signal. So let's do our classic. Put the question mark. See what we get. Okay. Is looking a little unintelligible from my point of view. So let's see how we can make this make a little more sense. So go to the dictionary. So let's go to shape. Format like that. Let's see what that does for us. So something equals shape. So we're looking for something that is a shape, right? So variable 0 squared plus variable 1 squared equals variable 2 squared. So right off the bat, I can tell you we're looking at, where is my what am I looking for? Triangle, right? A squared plus b squared is c squared. Where's my Pythagoras theorem? Boom, 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 boom. Am I being foolish? Being ghoulish? What am I missing here? I am being stupid because looks like we're actually graphing a circle, maybe? Formula to graph a circle. X squared plus y squared equals r squared. So I wonder if that's what we're looking at. Telling us a sequence. We also get pi. Look at this. We get pi continuous, something perimeter equals. Yep. So let's explain my thinking here. So the formatting's a little messy. Maybe we can look at how to clean that up a little bit. But let's look at this line right here. Variable 3 equals 3.14 continuous. So that's pi. So variable 3 is pi. So the something perimeter, which we assume this is circle. So the perimeter of a circle, in this case, equals variable 2 times 2. So we're assuming a variable 2 is radius, times 2 times pi, which is variable 3. Right? And then there's the area formula. We can check our math here. So area is radius squared, so variable 2 squared, times pi, which is variable 3. That's pi. So that tells us that what we're looking at right here, circle. And looks like the transcript is agreeing with us. Awesome. Defining a type of shape. Intriguing. I'd wager we'll soon see why. Back to wagering, huh? Oh no, those days are behind me. Okay. Let's recompile. Now that we know that this is a circle. So circle. Circle is a shape. Know that. And then here's our formula for that area. I'm trying to remember now. 2D geometry. Oh, this is a formula to graph a circle. Okay, perfect. And then sequence. I wonder why they say sequence here. Is that just breaking down the different mathematical equations we can do with the circle? Let's try and parse this out. Shape 0. So a circle and a circle equals a circle squared? Quite sure what that's trying to say. We're graphing a circle. That part confused me a little bit. This is clearly pi. Then we have the perimeter, the area, and variable 4 is x, variable 5 is y. Looks like, based off of this formula. And variable 2 is radius. Very interesting. I'm trying to think of what they're asking for here. So, go to the whiteboard. Maybe that'll help us here. So what they're asking is shape 1. Shape 1 is a circle. Then let me go back to the dictionary. Does then make sense? Right? Are we missing something here? Getting lost in translation. So, thus, arrow. Let's look at this. Let's rename then to an arrow. Maybe that'll make this a little more clear of what we're looking at. Then let's look at our formatting. Spaces. So circle is a shape. Here's how to graph it. So that's right off the bat. I think that's just was how we translated that. We know it's a circle. Let's skip that now. You know what? Go back to our formatting. No spaces. I think that'll clear it up a little bit more, maybe. And you know what? Maybe in a new line after circle. What will that look like? Or for this stuff down here. Circle perimeter equals this. Circle area equals this. It kind of makes sense. This is the only part that's confusing to me. Shape 0. We have shape 0. And shape 0 is a circle with a radius of variable 2. But that is all that's known. We know that. Now it's asking shape 1. What I'm missing is go back. Missing is what quite they're looking for, because they were saying this. They give us a second one down here. Variable 4 squared plus variable 5 squared equals 3 squared. So the radius of this equation would be 3. So are they saying what? 3? Yes. here's what I didn't understand about the formatting with that one. Go back. I guess I have to remember that they do things a little backwards. But you can see it's asking for... So shape 1's related formula was above the sequence start, I guess. Interesting. Which I'll have to keep in mind. I'll have to keep that in mind. So maybe, let's... To make the formatting make a little more sense. Go to dictionary... Sequence. And change it like that. That help us at all? Go back to the other one. See what it looks like now. Not really. We'll come back to that. We'll come back to that. There's a nicer way to do that. And then let's go back to the dictionary, because now our circles are getting numbered, so we don't want a space afterwards. Let's do that, Mamma Jamma. Alright. So circle 0 with a radius of 1. That's what this is telling me, I think. Circle 0. Radius 1. Is that nonsense? Circle 0, and I'll just put 1. So we know. We'll just assume that's radius. Variable 0 is pi. So circle 0 perimeter is so the perimeter of circle 0 equals 2 times pi. I don't think that's quite true though. If we go for 2D geometry. Oh, I see. So they're just saying 2 times pi times radius, but I guess because radius is 1, they don't care. So circle 0 perimeter, we already established, is just 2 times pi. Go to 2 pi. Multiply those. Then let's round that to... I'm trying to remember how we did this before. Copy that, paste that, and round to 2. 6.3. Let's give that a try. Okay. It's also interesting to note that they're skipping parts of the formula just because it's 1. So we might need to keep an eye out for that. Alright, shape 0 is giving us 4 points. X. You know what? I think let's change X, because X so far has only been about logic, right? Only been about logic, so I think let's change X to test. See what the hypothesis was. True, false, question, statement. But I like test, I think. In my head, then it means test. Is shape 0 a circle? I think that's false because it has 4 points, right? So why would we have 4 points on a circle? Quite frankly, we wouldn't. So, I think false. Let's see. Fantastic. Alright, so making sure we know what a circle is. So now we have another word. Let's recompile. So something is a circle with a point with 3. Okay, I instantly can tell you what this is telling us. A sphere is a circle with 3 dimensions. At least this is how I'm interpreting it. So let's see. And the dialogue, I feel, tells me we're on the right track. 3D circle? Sure. Sphere works. Yep. Fantastic. That is exactly what I was thinking. So sphere. And let's go back to our dictionary. Sphere. Change the formatting. Because I'm sure spheres will eventually be numbered. All right, so a sphere equals basically a triple circle. Kind of figured that out. The three-dimensional circle. Got 3 points. So sphere 0 with a radius of 1. Yeah, what's going on with area? Not having a... We don't need a new line after area, I think. Probably just a space. Same with round. Is round, because I think round, go back to round, because round, in this case, is always going to have a number before it, so I think we want no space. We know round to the nearest 2's place, basically, right? It's 4.2. So then, let's go to our references. Math, 3D geometry. So what is the perimeter of a sphere? Ba-ba-dum-bum-bum. Perimeter. Pi. Oh, it's just pi. Oh, but of course the perimeter of a sphere is just the perimeter of a circle. Because, bum, ba, dum, bum, bum, right? What's a sphere? Like a, I'm trying to think of how to represent this in my brain. You know what I'm saying? So a sphere, if you're looking at it from the side, is like this. And if you just want the perimeter, just treat it like a sphere. That makes sense. For reference, 2D geometry. The perimeter is 2 times pi times radius, which we know is a 1. And assume such. So that's just 2 pi again. So what was our answer last time? It should be the same as last time, right? 2 pi was just 6.3. Nope. All right, so clearly we already screwed something up. Let me see. Dun, dun, dun. Let's go back and let's see. What is the area telling us? Math, 3D geometry. Area equals 4 times pi times radius squared. Four times pi radius. Am I overthinking this? Probably. Reference, math. I feel like the perimeter of a sphere. Overthinking this somehow. I thought it would just be a. I thought it'd just be the same as a circle, right? Pi times radius. This radius is not 1. This radius is not 1. Could be. Although, let's think about this. Perimeter. Perimeter of a. I mean, what other formula do we have? We just have area. We could just try area. Do they mean just like the outside of a sphere? Because the outside of a circle is the perimeter, but the outside of a sphere is the area, right? That kind of makes sense in my brain. Let's think. The radius squared, that's just 1. So ignore that basically. So what's 4 times pi? Try that out. 4. Go get the. Yeah. Let's go get pi. So 4 times pi times, want that rounded to 2, please. 13. Let's see if that's correct. 13. Okay, so that might be good to keep in mind. Let's go to dictionary. So perimeter, go could be surface area for that's good to know. All right, so we have let's take a look. What do we have here? Let's look at our geometries. So we have something squared plus something squared plus something squared equals something squared. We have three sets of variables this time. So I'm thinking, here we go. Formula to graph a sphere. So what is it? It's a sphere. Okay. Ooh, okay. The music's bumping a little bit. We're getting up there. We're solving with the aliens. They gift us music. Let's see. Might turn it down just a smidge. Go. So, sphere 0, the radius of 2. The area of sphere 0, radius of 2, equals variable 0. The perimeter is variable 1. So what is the area and the perimeter? Can we deduce that from just those answers? Let's see. So in this case, first off, go back to our dictionary, because I'm feeling the same is going to hold true for area. So area could be volume in 3D context. I bet that's what they're asking for here. So 3D geometry, and we can do this because we have the radius. Take a look. So first we want the area for variable 0. So let's start off with, first it's going to be parenthesis, something, and parenthesis. First one is area. Second one is volume. And the names are a little confusing, so we might need to think about, it might be strange, but I almost want to call perimeter outside and area inside. Does that make sense? Let's revisit that. First, let's solve this. So first off, the volume is 4 over 3 times pi times radius cubed. What is that? 4 point. So that must be 4 over 3. So let's, okay. Boom. Let's go find pi. Is pi not in here? No. Go here. So this is 4/3 times pi. Times pi. Times pi. Copy that. And then we want radius. So in this case, 2 to the power of 3. 8. Then we want 8 times this number. And we round that by 2. Hopefully this is making sense, but it definitely makes sense, sort of, in my brain. That's 110. So let's respond. Area, or in this case, volume, right? No, this is correct. Surface area is 110. That's what they're asking for, right? Nope, shoot. I think we screwed it up. I think we did it backwards. I think they're wanting volume. Yes, so we did it right, but again, this is slightly confusing. So let's, you know what? Let's go ahead and do the dictionary rename. I know it's a little bit nonsense, but we're going to call perimeter outside. We're going to call area inside. Because that way it's easier to think about in the context of and 3D shapes. So, we just did the math for volume, so that's the inside of a sphere, which is variable 0, 110. Perfect. So now let's do volume. So that's just 4 times pi times radius squared. So radius squared is 4. So 4 times 4 is 16. What's 16 times pi, basically? Go find that. Here's pi. Pi, boom, times 16. And then we're going to round that 2's 50. 50. Give that a go. No, did not like it. Okay. Reassess. Let's reassess. Go to... Yeah, you know what? Let me look at the ideas. Let's see what they have to say. Make sure we're on the right track. Transition is another two-part what? Not a fan of those. No brute forcing. What are the two parts they're looking for? Inside and the outside of a sphere. Yeah. The radius of 2. What makes you think it's 2? 2 false sphere? Yeah, yeah. Guess the number, and by we, I mean Dr. B's. How gracious. Yeah. Okay, that makes sense to me. That definitely makes sense to me. Let me... Oh boy. See, I think, I think. I think we might have confused ourselves more by trying to do this inside-outside thing. Let's go back to what we were saying. Perimeter. Perimeter. And then we'll call this area. File. Let's check our math. Oh, they instantly give us 4 times pi right off the bat. That's fantastic. So, then radius is 2. So times 2 is 4. So it should be this times 4 for area. Let's see. Ba-dum-bum-bum. Ba-dum-bum-bum. This times 4. Round to 2. Still 50. Still 50. So let's check our volume equation again. That's our problem. Volume is 4/3. Oh, you know what? I bet this is already 4/3 times pi. We don't need the extra part. I was thinking they're just giving us the 4/3. I bet this is already 4/3 times pi. So we just need to multiply by 8. So let's take a look at this. Go calculator, paste times 8. Then we want to round that 2's, please. 34. Yeah, that's a lot more reasonable than 110, and that makes a lot more sense, right? So let's take a look. Fantastic. Okay, so we're on the right track. We're just making it harder for ourselves. So what's the area of a sphere with a radius of 3 and perimeter? I'm looking at here. Are they saying that it's the same? So sphere, the radius of 3, the area rounded to the 3's is equal to the perimeter of. I mean, I feel like instantly we can say false. Nope, that's not what they're looking for. Right? Because there's no way the area, the surface area and the volume are going to be the same, right? All right, let's check our math before we make such statements. So it should be, what's 3 times 3 is 9, times 3 is 27. So this times 27 is our quote-unquote area, right? So area equals volume equals, we'll just use this as our little clipboard, I guess. This times 27. Copy that, paste that. Want to round that to the 3's, please. That's 113. Okay, so that's our volume or area in this case. See, again, I'm confusing myself. Then this would be perimeter. Works, that makes sense in my brain. Let's go calculator. I'm sorry. Get our numbers. For surface area, in this case perimeter, kind of. And just radius squared, right? Yeah, so just 3 times 3 is 9. So paste times 9. Calculate. Oh my goodness. Guess what? Guess what, folks? I think we are foolish and ghoulish. I think it is. It is the same. So we're wrong. So it's true. That's true. Are they not looking through? Is that what's happening? Or is it just one number? Because they're both the same. Right. Okay. I understand. I see now. Wow. Okay, they're throwing 3 different things to us here. Okay, so we're going to call this X, Y, and Z. Holy cow. The first spatial dimension, that works. No clean? Come on, Batista, it's only 1 character long. And not feeling it, maybe later. Did we accidentally get that completely right? I mean, holy schmackerels, we're geniuses. Hey, Batista, it's only 1 character long. I see. Dr. B's entered Y. Come on, buddy, you know you wanna. And come on, give me the last one. Batista, you said maybe later. Now's later. D. Okay, I admit. Clean. Yeah! Okay. I mean, to be honest, that was totally off the cuff, but it's very funny that that happened to be correct. I mean, I guess it was bound to happen, right? X, Y, Z for our 3 dimensions. So now we're getting really interesting. Oh, not really, because now they're just saying, can you read this properly? X, Y, and Z. So Z is 8. But now we're getting into 3 dimensions. So now we're going to have to put our thinking caps on a little bit here. Alright, so here's a shape. I see what they're saying. They're saying you go from 0 to 1, continue up to 6 and 7. So they're saying 0 through 7. So there's an 8-pointed shape. Yep, and that's exactly proven right there. Okay, how can we parse this out so it's a little cleaner to understand? Let's go to our dictionary. Can we give shape a new line beforehand again? I think that might help us out a little bit here. A little better. So they're saying this shape has 8 points. We know that to be true. This shape has 3 variables per point. Yep. So the shape's x variable, y variable, and z variables, how many variables do they have? I see what they're saying now. So my assumption would be, let's do 3. Well, I don't need to calculate for that. 3 times 8 is 24. Does that make sense? Because there's an x, y, and z coordinate for each point is what they're saying. Let's try it out. 24. No. Okay. So what are they saying? Shape 0. Or does the shape itself only have a single set of variables? I see what it's saying. So, let's go back and explain that a little bit. This is saying the shape itself has a distinct set of x, y, and z variables of where the shape is. It's also saying the points technically have their own x, y, and z. But the shape, the larger shape itself, is what matters, right? So if we're trying to graph something, right? Let's say the point is here, the point is here, the point is here, the point is here. We draw a shape in between. The position of the shape is a distinct set of coordinates compared to the points that make up the shape. That makes sense. So now what are we looking at? Okay, we got a complicated order here. First off, again, let's try and clean this up a little bit. Let's go to our points. Base. So now they're saying, because the shape variable count is 2, it's a 2-dimensional shape. Yes, okay. They're making it pretty clear to us here. So they're saying shape 0 is made up of points that only have 2 dimensions, right? So you can see there's no z variable on point 0, point 1, point 2, there's no z. So the actual variable on the shape itself only has 2 variables, an x and a y, no z. And they're showing that here. So the space 0 points are x and y. Okay. Again, they're making sure we understand the difference between 2 and 3-dimensional shapes. I'm sure it's going to come into play, and we better be ready. Okay, so shape 0 has 4 points. And again, I apologize about the formatting. There's got to be a better way to do it that I'm just not quite seeing. You know what? You know what I want to do, folks? I want to go back. My beautiful dictionary. Let's go to points. I know I seem to change it between every transmission, but it seems to work better for different transmissions, different times. So shape 0, made up of 4 points. So shape 0 is probably a square or rectangle. Looks like this proves that to be the case. So, the length of x is variable 0. The length of y is variable 1. And we know that because it goes 0 to 6. Graph this. Is a rectangle. 0, 0. 0, 5, 6. 1, 2, 6. 2, 0. There's our beautiful rectangle. So the x length is 2. The y length is 6, right? Goes over, 2, up. Let's make sure that's true. So 2 and 6. But let me see. I think they do want the parentheses on this one. Let's throw those in. Beautiful. Alright, Meteor. We're understanding. A 2D circle is a what? What are they saying here? Or are they saying a circle with 2 variables has an x and a y? Is that what they're asking? Yep, okay. We understand that. And a sphere has what? A sphere has an x and a Y, and a Z. Beautiful. Alright, these ones are making a lot of sense to me. Okay, now we're getting interesting. So a sphere. Alright, know what I'm gonna do? Back to the dictionary. Let's go to spheres. Spheres. And we're gonna give this a new line. Hopefully it'll make it a little clearer for us. There we go. Alright, so it's telling us, here's the sequence. We're going to get a sphere. And again, I'm going to do it. I think sequence needs to be a little cleaner. Sequence. One new line each. I'm sorry, we want two each, don't we? Yeah, because this is showing us, here, pay attention. The area, they're going to give us the area and the XYZ coordinates of each sphere. Boom. Okay, so they're telling us 1, 3, 5, 7, and what? They want us to have an imaginary sphere 4? I believe so. Let's follow the pattern. So area is going up by 2. Yep. Area is going up by 2. X is going up by 1. Y is going up by 2. D is not moving. Let's try that. So it's going to be and so sphere 4. So that should be 1, 3, 5, 7, 9. And then we want 4 and 8 and 0. All the patterns. So 4 and 8. Let's see what they think. It's a long message. They like it. They like it. Still do some deductive reasoning. Mr. Meteor. Okay. 1, negative 1, negative 1, negative 1. 1, negative 1, negative 1. Okay. Right off the bat, it looks like we have a cluster of spheres in a circle. So it looks like we have 4 with a negative x. Must be 4 with a positive x. Okay, so instantly let's think about this. Because they're saying sphere 0 through to sphere 7 is shape 0. What the heck is shape 0? We're talking about a cluster of spheres in a circle together. Don't know. Don't know. That's interesting. I'll have to think about that. Okay, so sphere 7. So let's follow the pattern. So we have negative x, negative x, negative x, negative x, positive x, positive x, positive x. So this must be positive x. So instantly we're going to say 1. And what are the y's looking like? Negative, negative, positive, positive, negative, negative, positive. We can go ahead and assume that's going to be positive. And then let's look at the z pattern. So the z pattern is negative, positive, negative, positive, negative, positive, negative. So let's assume it's going to be positive. See what it has to say. Correct. Okay. Again, just pattern recognition for now, but I don't know what this will mean later on. Wow. Okay, so we have a huge sphere and a tiny sphere way up high. Okay, first off, I'm instantly thinking signal for move might be something else. Because sphere 1 move and sphere 1 move and sphere 1 move. So if we continuously are growing sphere 1, shifting sphere 1, translating sphere 1. Then they're saying, is sphere 1 going to be bigger or smaller than sphere 0? So if we're moving it, if we're shifting it, if we're translating it, we're not changing the area. So sphere 0 will always be bigger than sphere 1, right? Let's say sphere 1 smaller than sphere 0 in this case. Correct. Okay. So again, they're testing us. They're testing us. And here we have one where they're just giving us a name of something that we don't understand yet. So sphere equals possibly shape. Possibly shape. That means maybe. Look at the dictionary. Do we have a word for shape yet? Object, area. Shockingly, no. Let's say shape maybe. Shape. No, we do have a shape. We have a shape. Of course we have a shape. What am I saying? All right, let's leave it as question mark for now. This is the classic what equals 0. This is an informational transmission that we don't quite understand yet. Okay. Now we're getting interesting. Here's 0. To here's 0 equals what? What? Maybe question mark 0? 0? No. Maybe just question mark? But what does the question mark mean? Because we're seeing this, they're defining it for us here. What does it mean? It's something that's a sequence. Okay, let's think on that one. Call this one 1 for now. Because no idea what this one is. So something with variable 1. Or variable 0, I'm sorry. Variable 0 is larger than -1. And variable 0 is less than 65. What equals 0? 0. But what is that telling us? That telling us? All right, so let's check our math. Because I'm thinking we're still in this sort of zone. Also, look at this. We're on transmission 199. Gotten pretty dang far, huh? Alright, let's think about this. Down. Trying to think here. Party the music. Okay, so sphere 0, variable 3. All right, so let's work backwards first off. We've got X, Y, Z. Have we named radius yet, or have they just told us radius? Is that what we're looking at, possibly? Try it out. R or radius? I don't love it because I feel like they would have said something. Alright, so we got our X, Y, and Z. We have our radius as variable 3. And something equals 32. Or are they finally... Hold on. Let's go back. Are they finally differentiating between surface area, like two-dimensional area versus area? Hmm. So this mystery 1 variable. So first off, it's asking for all this information, right? So let's just give it X, Y, and Z because we know that. Neg 1 and 12 and 8, 5. There's the X, Y, and Z. And the area. So what's the area? The area equals variable 3. And something. And 32. Because they already told us mystery 1 variable equals 32. Still have to name that variable. Guess this should be var 3 if we don't know. Var 3. Let's try it out. Let's see what they say. Okay. So what did that tell us though? Still a little lost on that one. Place spheres. What could this one variable be? Desperately want to know. Okay, so now we have another mystery variable. I'm just going to call this one 2. We already have a question mark and a 1 sitting out there. So our actual deciphering of words right now is not fantastic. Something sequence question mark what equals 0. Okay. Classic what equals 0. Purely informational. Hey, over 200 now. Holy schmackerel. Okay. Wow. Okay. So what is the count of variable? Is it... Wait a minute. Okay, is it one of these constants that we know about? Is it pi? No, doesn't quite make much sense, does it? Maybe these are called. These be called coordinates. Would that make sense? Let's see. And then these are sets of coordinates, right? You know what I'm saying? So what did we say last time? A coordinate has 1, 2, 3, 1, 2, 3, 4, 5 variables. So 1, 5, 1, 2, 5, 5. Looks like they're not trying to trick us. So let me just count the number of coordinates. 1, 2, 3, 4, 5, 6. Yes? I guess the answer is 6 sets of coordinates. In which case, let's go ahead and change this down to just chords. Not having a huge mess of stuff. Cut the spaces. Okay, I think, looking at how they're formatting this, I think we're vaguely on the right track. So here's an object with 3 sets of coordinates. Why would it need 3 sets of coordinates? Alright, you know what? Let me look. Can I set a, might be a funny one, a colon? I can't. Give that a shot. What's that look like? That kind of works. 0, 1, 2, 3, 4, 5, and 6. Oh boy. So I'm trying to understand. What's bigger, an object with 6 coordinates or an object with 4 coordinates or an object with 3 coordinates? Frankly, I have no idea. I don't know what 1 and 2 are in a true fashion. Just guesstimating, right? I guess I'm gonna go ahead and say object 0 is smaller than object 1. See if that helps illuminate the situation. Nope. Okay, let's see what they have to say about it. Shucks. Guess it's the other one. Really pulling for smaller too. Okay, so just wrong. But why are 3 coordinates more important than 4 coordinates? That one, I gotta read the hypotheses. I would love to see what they're saying on that one. I'm missing something there. But we got through it. Got through it. Where's Batista? Didn't he call this meeting? I think to get rid of us. What? I wouldn't put it like that, but yes, Dr. Batista said it was best we cleared the room. Well, he doesn't get to make that call. I want you all working on the translation. Yeah, you tell him, boss. Just a moment, Dr. Doppler. He's doing so in our best interest. Said he needs us to step away so he could program something. Ooh. I'm hoping some sort of 3-dimensional graphing tool? And he did say if we didn't have some new program, it would be difficult to continue. Better not be another confetti situation. Confetti? What are we talking about? Shh, don't tell him about the confetti. Now, wait, what's this about confetti? We cracked the alien's language. I'm listening. Alan, tell me how. Learned how to communicate with a sphere. What a sphere is, with sphere. And you used that to learn how to master energy and intergalactic travel? We're getting there. Dr. Akers may be overplaying our progress. Yeah, I was starting to realize that. Regardless, I trust Batista's working hard. I think even if he wasn't paid, he'd want to be here working on that computer. Maybe I could save some budget there. Yeah, you could give his salary to me. Never mind. Hey, Dr. Bees, did we ever get some clarity on that transmission we discussed last week? An alien or Earth again, so we have nothing new with which we can proceed. Yeah. That was an interesting one. I feel like that was our first sort of attempt to almost communicate, and then they sort of stepped back. Maybe they're not sure that we're actually ready yet. Let me know if that changes. Let's head home. Good night, team. Good night, Dop. Sweet dreams, everyone. All right, so that was a pretty solid week. Let's see what our numbers look like. We actually got through a decent amount, I feel like. Yeah, 23 transmissions. Learned 8 new words. We're above 200 total transmissions now. 54 words total. We named circles, sphere, X, Y, Z, coordinates 1 and 2. Now we have circles and spheres, spatial dimensions, and place spheres. Yeah, the 1 and 2, I'm really questioning what they're going to say hypotheses. Because I feel like that one just whoosh right over my head, and we just kind of muddled our way through it. But we'll see what they say. Alright, so Alan's status is good. Was kind of hoping I could get a trophy this week, though I didn't do anything to stand out. And Dop didn't even get one out at all. Batista has nothing to say. Carrie says, Dear Diary, it was a surprisingly mundane week for how climactic last week's transmissions appeared. Perhaps I've missed some subtext of the latest transmissions, or perhaps it's merely building to a peak. Yeah, I feel like if we're plotting in 3 dimensions with spheres, they're going to try and make us a map, maybe, like of the solar system or planets or something. Still never found out what the confetti was all about. Sounds mischievous, says Dr. Doppler. And, of course, Dr. Bees, he's just thinking about bees. Oh, shoot. We only get hypotheses for circle and sphere. Man, oh, man. Okay, so we're still on our own for the rest. We're going to have to muddle through, I think. Or hopefully figure out what they mean through the rest of these transmissions. But let's see if we get a quick dialogue here. He was working on a computer. Wow, big transmission. Looks like they got nothing to say. So, awesome. I will leave it there. Oh, they do have something to say. See? All right, we're back. Good morning, everyone. So, what's the update, Batista? I've been curious about it all night. Visual window. The message contains 2. Okay, if a message contains variable 2 with coordinates, this window will draw the coordinates as described in 3D space. My best interpretations of sequence sphere. Oh. Wow, look at this. Are you kidding me? Oh, ho, ho, ho. We now have 3-dimensional representations. Oh, hold on. This is amazing. You can control the zoom and rotation with 2 of the scroll bars. Batista, it's unbelievable. My research is often focused on graphics programming, and it's unfair to say I did this entirely overnight. Oh, look, he's being humble. Humility doesn't hurt, Akers. This is incredible. Look at this. This will give us a lot of insight into what the heck these creatures are trying to tell us. I have a feeling we're going to start getting into atoms, molecules, maybe? I don't know. I don't know. But this is pretty cool. Pretty neat. Alright, so yeah, I'll leave you with that. And we'll come back for week 14 with all these new gizmos and gadgets. See what we can figure out.